Hi Jagdish, good afternoon.
Hello, hi.
Hi Venkat.
I'm very sorry. I'm a
Good
little
afternoon. Good morning.
confused. So tomorrow we will also have manual testing approximately at 10 o'clock in the like now, right?
Yes, that is correct.
Okay. Thank you very much.
Yeah, should we start?
Hello,
Um,
Gibran.
hello.
Good morning. Yeah.
Can everybody hear me?
Yes.
Yes.
Perfect. Okay, are we still waiting for some people? Can start in maybe a minute. Um, okay.
Yep. Hello all. Both my kids are at home today, as my younger kid is sick. So I will be quiet. I can't be much active today. So Vedran will lead the session today. Vedran, so thanks for handling this. Please take care of the session. I will be here. If you need anything, you can just ping me or ask me.
Yeah, of course.
Yeah.
And yeah, so yesterday we had a very elementary look at manual testing, and yeah, we had a lot of concepts and maybe a bit too much, but of course, you're not expected to memorize all of them at once. So today we are going to start off with actually repeating yesterday's session with a quiz, and let's see if this works. I've sent the link in the chat. And that should take you to the quiz. Uh, yeah, and there's 18 questions. And we'll take, yeah, I think that should take about maybe 10 minutes or 12 minutes to complete. And then after that, we can just discuss the answers. And then we'll move on to, yeah, today's session, which is more focused on the software development life cycle very briefly, which we touched upon that yesterday. But today we're going to go a little bit deeper into it, and we're going to talk about testing activities and test levels. And we'll see how much we can accomplish today. But first, do the quiz. It, let me just ask, is it working for everybody?
Where have you shared?
It's in the chat. Did it reach?
No, we haven't received it.
Maybe not. Okay.
Yeah, now we.
There we go. Yeah. So you just write your name or nickname, and then you can start the test yourself. And it's multiple choice. And yeah, I think it will take about 10 minutes or so. Even if you don't manage to answer all the questions, we'll just go through them. Okay, let me see. And please let me know if it's working for anyone. If you're logged in. Okay, I see 2 thumbs up. That's good. Okay. Yeah, let me share the. Okay. So you can either, there's also a QR code. If you prefer to do it like that, I have the link sent in the chat and also QR code. Yeah. Is it working? Okay. I see 7 participants, so that's good. 8 now. So some people have recently joined, and I'm gonna send a link again in the group chat. Let's see. We're doing a quiz for everybody that has joined. Multiple choice quiz. Just to recap yesterday's session. And also, I want to mention before I forget, the material from yesterday is on the drive. There's the glossary of some of the words we discussed yesterday. And there's also these little infographic about the 7 principles of testing. It might be helpful. So please check that out. I can see some people have joined, but have not answered any questions. So please let me know if everything works for you. Okay. Yeah. Somebody's asking how to join the quiz. You can follow this link in the chat and sign up. Just use a name or nickname, and you're ready to start the quiz. So one person. I see 3 people. I think 3 people have finished the quiz by now. Don't worry if you don't finish it. We're gonna go through all the answers anyway. And don't feel so pressured to get everything right. Some questions are a bit tricky. Okay, let's wrap up the quiz. I think it's about time. I'm gonna end the quiz now. So Yeah, well done. Okay. Let's see here. Okay, let me share the screen. Anyway, yeah, for those who just recently joined, we did a quiz, just a recap of what we talked about yesterday, some terminology and some concepts. I have uploaded the glossary on the Google Drive, so please have a look at that. Some words will come up today also. And there's also the 7 principles of testing, which we discussed yesterday. So please have a look at that. And let's start. Let me share screen. Yes, you all see? Let's move this. Okay, question number 1. Which of the following statements describe a valid test objective? And it is to reduce the risk level of the test object and to build confidence in the quality level. Now, here's the thing. You cannot prove anything, so you have to look at the wording here. You cannot prove, for example, on option B, that there are no failures after implementation. You can never prove that. And same with answer A. You cannot prove that there are no unfixed defects, because this goes back to the first principle. You can only show that there are defects present, but you can never know which ones are not there. And of course, C would be also D, sorry, would be also incorrect, because you cannot verify that there are no untested combination of inputs, which goes to the second principle. You cannot test every combination, except in very small trivial cases. But as it scales up, you cannot test everything. Okay? And of course, please stop me anytime you have a question, if you want some more explanation of anything. Okay. Question 2. One of the principles of testing states that exhaustive testing is impossible. Which of the following is an example of addressing this principle? So exhaustive testing meaning test everything. And I just, from the previous question, if you remember, creating test cases that cover every possible specified input. Answer A. That is, yeah, this is an example of something that is not possible. The other, this has to do with prioritization based on importance. That's something we'll talk about later, so don't worry about that. Starting testing as early as possible. That's another concept. Equivalence partitioning, also don't worry about that. We'll talk about that in a later class. But exhaustive testing, meaning test everything, which is not possible. Okay, what advantages does manual testing have over automated testing? And the answer is A. It allows testers to explore the application and identify unexpected issues. So with manual testing, it's more human, that you would maybe look at a website or a login screen, and you can see something that's unexpected. You have an unexpected error, or unexpected characters shows up, or anything like that. If you test anything, that's something that maybe automation misses. So for example, if you have an automated test, and that would automate login of a website, but you maybe when you're doing it manually, you maybe ask yourself, what happens if I put a smiley face in the password field? Do I get an error or do I not get an error? So these are the kind of things you can see with manual testing that you cannot see with automated testing. Okay. And B is wrong because it's not faster than automated testing when it comes to repetitive tests. It does require documentation and planning. It is always cheaper. It is not always cheaper to manually test, especially as it scales up. You have a finished project, then manual testing will be much, much more expensive. Moving on. Which of the following is an example of why testing is necessary? So testing helps make software fail in ways that users should not experience, is the correct answers. Yeah, so this is a bit of a trick question. Developers can find and fix problems earlier by checking their code before running the program. That is true, but that is not a reason why testing is necessary. Okay. And yeah, C, of course, app software doesn't produce no output, is not ready to be released. Yeah, again, D, reviewing requirements helps finds mistakes early, reducing problems later. True, but that's not a reason why testing is necessary. So moving on, which of the following statements best describe the difference between testing and debugging? Okay. Testing causes failures while debugging fixes failures. This is a trick question. You cannot fix a failure. So if you remember from last class, a defect or a bug is in the code, and when you execute it, you cause a failure. You cannot fix failures, you can only fix bugs, which is why D is the correct answer. Testing finds the cause of defects. They find the defects, and the debugging fixes the cause of the defects. You remove, okay, you have a defect that the tester finds. Here is a defect, and the debugger removes that defect. Okay. Which of the following is an example of debugging? A developer finds and fixes a defect. Also a little bit of a trick question. As you remember, different roles in testing. A developer can also be a tester. So this is an example of debugging. A developer, it can be a very small team. Sometimes a team can be as big as maybe 2 or even 1 person. There's not always a dedicated tester. Sometimes a developer, you would develop the code, you would develop the software, and you would also test it yourself. There are cases like that. So that is the correct answer. Let's see. Yeah, our tester retests the fix when the developer finds a bug. This is just finding bugs, it's not debugging. Tester finds a defect and reports it. That is testing. It's not debugging. Debugging is, of course, removing the bugs itself. So just finding it and reporting it does not make it debugging. Okay. Next one. Which of the following is a true statement about exhaustive testing? Again, testing everything. And the correct answer is, it is not feasible except in trivial cases. Okay. Let's see. 2 people said it is normally the responsibility of the developer during unit test. This is not necessarily true. Again, a developer can be a tester, but this is not necessarily true. Right? What is quality? Quality is simply the degree to which a work product satisfies stated and implied requirements. We talked about validation requirements. It has nothing to do with any kind of professionalism that goes into the product. You can have a very small team, a very small company making a software, and it can still be great quality. You can have a big company, very famous company, still making software, and it can still be low quality to it. So it has nothing to do with that, and it has nothing to do with how fast you can deploy it. Yeah. When should testing begin in a software project? And everybody got this correctly, as early as possible. Not very difficult. Okay. Why is it important to avoid the principles of test wearing out? Okay, maybe a bit tricky, but running the same test repeatedly will reduce the chance of finding new failures. Yeah, and it is the opposite. Running the same tests repeatedly will consistently find new failures. It will not consistently find new failures because of the system. A software might be redesigned in a way, and if you have a test that only tests the login screen, but it doesn't account for any other new element that's been added to it, then of course you will not find a new bug. So correct answer is D. Okay, you have a software product made exactly according to requirements and has been tested without all major defects resolved. However, the customer is not happy. Which principle does this reflect? Okay, this reflects the absence of defects fallacy. Even if your software is free of defects, it doesn't mean that the customer will be happy. Right? Principle number 7. When can a developer act as a tester? And the correct answer is a developer can always take up his role as a tester. Oh, it's an and accidentally came in there. But roles, we talk about roles. A developer can test. A developer must also test in every stage of the software life cycle. Two people said, not necessarily true. They don't have to. A developer can test, but also not do it. Okay, so its answer is D. Okay. What is the developer's main responsibility? Everybody got this correct. Create and improve software. That's the main. Okay. Who is a stakeholder? Is someone who has interest in the success of the software. Right, so answer is C. Which statement best describes a defect? Yes, so again, this is the terminology. It is not mistake made by a user, that's an error. Mistakes cause defects. So the right answer is B, a problem in the software caused by a mistake or an error. Mistake, this is synonymous with error, right? According to the 7 principles of testing, why can testing prove that software is completely bug-free? Yes, again, prove. The right answer is B, because testing can only show that bugs exist, not that none remain, okay? Principle number 2, you cannot prove that there are none. And number 1 is incorrect because, of course, testing is not done after release. It can be done during development, right? Which of the following is one of the 7 principles of testing? It is early testing, saves time and money. None of these are principles. Yeah, this is also not true because it violates the second principle. Exhaustive testing is not possible. You cannot remove every bug. Okay, last question. What should a tester do when they find a bug? Report it clearly so it can be fixed. Correct answer B. Should not ignore it. You should not retest it and hope it gives a different result. You should not try to fix the code yourself. Okay. Any questions? Oops. Any questions at all? I'll give it a minute. Let's see. Yeah, so as I said, on the drive, I uploaded the glossary and the 7 principles of testing. So please have a look at that. You will find words like error, mistake, developer, debugger, tester, what is quality, yeah, and yeah. So please have a look at that. Okay. How we doing time-wise? I think we can start. So again, if you don't have any questions, I will start the next session. Right. Just give me a minute. Huh? Just go ahead. Yes. Let's do it like this. Okay. Do you all see it?
Yes, thank you.
Okay, great. Manual testing session 2. Yesterday, we took a look at what we just repeated, a lot of words, a lot of concepts. Okay, today we're going to talk about the software development lifecycle and the development models. We did very briefly touch upon this yesterday. And we're going to talk about test activities. What does a tester do during all of this? So there are different ones. There's the test types. You can test in different kinds of ways, and there are test levels. So we'll try to go through all of them today. But again, yeah, we'll see how much time we have. And of course, don't feel pressure to learn all of this. I will, of course, upload as I did today with all the with the first session, the documents. So I'll also upload a glossary for today's session. Okay, so today, as we discussed yesterday, there is the software development life cycle, and there are many models of it. We're not going to go into detail of every model, at least not today. But what I want to say is there's the 2 main types, which is an iterative model and a more linear model. And we can take a look at the first one, which is the waterfall model. This is very linear. You would start the process with requirement analysis. Here you would check the requirements. What does the customer want? The specifications. If it's a website, what's the color of the website? What kind of buttons should it have? And yeah, things like that. And then you would go to the design phase, and you would design, sketch, and see all the how you should implement it. And then there is the implementation, where you actually implement all the features that they want. And after that, you have maybe a functioning website. And only after that would you do testing. And this is where you would test everything, and find all the bugs. And after that, it would be done. You would have the deployment, and after deployment, and deployment means you would sell the product, you would deploy the website, you would sell the product, the software. And after that, you would have the maintenance phase, that's when you can go back and fix some bugs. There are versions, maybe there's version, you've seen it, version 1.1, version 1.2, stuff like that. So that's a waterfall model. It goes very linearly. So the important thing is you don't go back to a previous step. That's the main takeaway here. So once you are in testing, you do not go back to implementation or design, or when you are in deployment, you don't go back to testing. Only in maintenance do you fix some maybe smaller bugs, if there are. Okay. Now, this is a iterative model, agile. This is one type. And the main point here is that it is not linear. You can have different stages, just like the last one, except that you would have, for example, you call it sprint. In the first sprint, you would do the analysis, design, testing, and then deployment in the first sprint. So if we say, for example, this is not software, but if we say the customer wants a vehicle with wheels, okay? We don't know what it is. Customer just says, we want a vehicle with wheels. Okay. First sprint, we make a skateboard. It has 4 wheels. You stand on it, you move, and then you move to the next sprint. You maybe consult the customer. Is this what you want? This is a vehicle with 4 wheels. Okay, maybe no. And then you move on to the next one. You maybe redesign it, tweak it, and then you have something different. Maybe you have a scooter. So you would do again analysis, design, testing, deployment, and you would have a finished product. So in every stage you would have a finished product. Yeah. And then in the next stage, you maybe design a bicycle, and the next stage a motorcycle, and then maybe finally a car. But the thing is, the customer can at any point of these stages say, oh, wait a minute, I'm happy with the bicycle, right? So as opposed to a waterfall model, you would go through all these and end up with a car. But in an iterative model, you make small changes, and maybe the customer will be happy with something that is not the final stage. So yeah, that is sort of the gist of it. And yeah, I think Jagadish, if you want to pitch in a little bit, who has had many years of industry experience, maybe compare these two if you have a quick word to say. Okay, maybe unavailable now. But yeah, so these are the two main, as I mentioned. Yeah, there are many different models, but it's the main comparison I'm making here is the linear one and the iterative, that you can iterate around every stage, right? And moving on. So here's the thing. Test activities, there are different ways to test things, different things to test, and all of these sort of stages, right? So, for example, you would have planning, and this would all take place in the model itself, right? The test. So if you look, for example, at a waterfall model, the testing stage, inside of that, you would have maybe these activities, right? First activity is planning. So before we start testing, we would need a plan. And of course, we decide what we're going to test, right? How we're going to test it, who will do the testing, and when it should be completed. Right? So think of it like a road trip, right? Before leaving, you decide where you're going, which route to take, how long it will take. That's very important. Like here you plan also budget. That's very important. How much you will allocate to different kinds of testing. And of course, it works the same way. We need a clear plan, what route to take, and so forth. You would define the test scope, the objectives, resource, schedule, budget, and schedule. And then you would have monitoring. And once testing has started, so we don't just let it run without checking it. And monitoring means you keep track of the product. We ask questions like, are we on schedule? Have we found any serious bugs? And are there any problems slowing us down? If something isn't going according to plan, we can make adjustment before it's too late. And the thing is about monitoring, it can actually be done in any of these activities. So it is done throughout. You will always monitoring, even though it's the second on the list here. All right. We then go to analysis. And before we write any test case, and test case is simply how we test what to test. Test case could be login. I want you to test the login screen, and yeah, simply like that, and click login. Enter email, enter password, login. That can be a simple test. But before we write these test cases, we need to understand what the software is supposed to do, right? So during this stage, we read the requirements, we read the user stories, also a term that will come up later, or the specifications, right? And here we identify features that need testing and think about what could go wrong. For example, if we're testing the login screen, we know we need to test the valid logins, the passwords, the empty fields, so maybe either very long usernames or where the @ is. What happens if you have a software that's checking something @ something.com, but maybe wouldn't check two @ or maybe two .coms. Maybe it only checks if it ends with a .com, right? So the analysis, it helps us decide what to test, right? Okay. And design. So after we decided what to test, we designed the actual test cases. Here is where we actually designed after we analyze this. So that just means we're creating tests. We're creating test cases with clear steps and expected results, right? We should do this, like a checklist, and this should happen. So we also prepared the data we need. For example, if we're testing a login page, we might create one valid user account and several invalid usernames and passwords. So good test design makes testing consistent and repeatable instead of it changing all the time. Okay. And then we would have implementation. So before we execute the test, we need to prepare everything. And this is called implementation. We set up the testing environment, install the correct version of the software, and make sure we have everything we need. So you can think of it as maybe setting up a dining table. Before you serve the food, you have to set up the dining table. Plates, forks, glasses, or maybe you sit in a classroom, you're a teacher, you want to arrange the chairs in a simple way, the desks and chairs. Maybe you need to turn on the projector if you're using the projector. So that's implementation. You make sure everything is correct before you execute everything. And once you do that, you come to the activity that is the execution. So this is the part where most people think about when they hear the word testing, right? You think execute the software, that is testing. But the truth is, all of these are testing activities, right? But this is the one that most people think is testing. This is where we actually perform the test cases. We follow the test steps. We compare the actual results with the expected results. We expect, if we test the login screen, that it will log in, but unexpected things might happen. Maybe an error, app crashes, maybe it takes you somewhere completely different where you did not expect, right? And if something doesn't work as expected, we report it as a bug. This is the activity where we discover whether the software behaves correctly. Right? And once you have done that, you are in the completion phase. And after all the testing is finished, we don't stop. It's not, okay, we tested, there are no bugs. End of that. But that's not true. We have to ask questions like, did we meet our goals? How many bugs did we find? Huh? What went well? What could we improve next time? So here's the activity where we have a lot of documentation. And that's very important. If you want to retest things, you want to look back and see what kind of documentation we had from previous tests. What can we learn in the future to be more successful looking at this? So yeah, these are the test activities. You notice that it's testing is much more than just clicking buttons and finding bugs. There's a complete process behind it. We go from planning, preparation to execution, reviewing. Yeah, following these test activities helps test teams, it test the software in an organized and efficient way, right? So that's what we have in the testing phase. And in the iterative model, these activities happen in every sprint. So you would have a planning, monitoring, analysis, design, execution, implementation. Then you would go to the next one, and you would do the same thing. Okay. Any questions so far? See how we're doing on time.
Do we have time or we don't have time?
For questions, we do have time for questions.
Yeah, but maybe at the end we don't have time, so maybe it's a good idea to finish and then we can ask. Or because
Okay.
yesterday the Jagdish told us that we were run out of time.
Okay.
Okay.
Yeah. Right. Then I will do this. Yeah. We'll look at test types and test levels. Yeah. How many different ways are there to test the software? I'll make it a bit interactive. If you think, say you have something like a login screen, how many ways are there to test the software? Just think for a minute and, if you have a login screen, you, as a tester, say you are a tester, just what would you check? Anybody?
Like if we have the login screen. So
If
for,
you just have an app, yes. What would you test? You're a tester. What would you just check to see if it works?
To write every possible how it's called.
first we'll check whether that login
The
page,
UI is loaded properly or not.
yeah, is it accessible?
Okay, yeah. Is it accessible? Does it show?
Yeah.
Right?
Yeah.
Yeah.
Then we'll check the UI of the login page, the username, the password, like whether it's according to the requirement.
Yeah. You would check the password. You would check the email address. Anything else you would check?
And the login, how long it took to log in? It's a
That's a
kind of
good one.
performance
Log
testing.
in. Yes, you would say you would check the speed. If it takes 30 seconds to log in, is that really good? And no, not really. That's not really a good user experience, even though it does work. It takes a long time. Maybe you would also look at how the login screen interacts with another element, right? How does the login screen act with an account that you have, maybe, right? So we have test types and test levels.
And
Yeah,
if it is
sorry,
not
Robert.
breakable,
If it's
if
breakable, yeah, exactly. You would put maybe a smiley face. Maybe you can copy a picture and try to put it in the password field, see what happens. You have to try everything or everything you can think of, right? Test levels. Yeah, there are different types of levels to test. I'll go through them very quickly, but we have, for example, the login screen. The first one is component testing, also known as unit testing. You will test one unit. You maybe have a whole system and you test just the login screen. There's the account, there's the comments, there's the where you order things, the basket, whatever the app is, if it's. So you would test just this, or you would test a very simple thing. If you know, code, like 1 + 1 = 2, that's a very small test you can test. Is it true? So that's what you would do in a unit. Now, unit integration testing, you integrate it, okay? You have two units, see if they work together. Simple as that. You have a login screen. Does it link to, say, the account that you have? Because what's the point of logging in if you can't see your account, right? Yeah, it's simply as you have units, small pieces, and you test them together, see if they're integrated, okay? And then when you have all these units together, you might have a system. This is where you test, is the whole system working? All the units together, are they working? Like that could even be a operating system. That's a huge undertaking. Literally a whole system. Is the whole system working together, right? This is where we act like real users. We use it as a user would, not testing as maybe, see if a code and a function works correctly. You see if the whole system works. And after that, we have system integration testing. This is where we see, does the system integrate with other things? Maybe you have a whole system, but can it connect to the Wi-Fi? Can it use internet? You have to see if the system connects with another system, a whole Wi-Fi, a whole internet system. That will be system integration testing, okay? And once you've done that, you come to the last one, acceptance testing. And this is the final level. At this point, we're asking different questions, We're no longer asking, does the software work? Instead, we're asking, does the software meet customer needs? Acceptance testing is often performed by the customer or the people who will actually use the software. So, if employee management system, you have that, maybe HR department will test it and see if it works. See if they can add employees, generate reports and stuff like that, if everything meets the requirement. Now they accept the software and it's ready to go. And perhaps you heard of beta testing. Maybe there's a term you heard, because there's testing and the team, alpha testing, and then there's beta testing, which is also called field testing. Now you have a product, you have a test, you deploy it, and the people test it if it works. For example, the HR person tests if it works, and if they're happy, you have the validation, right? Yeah, I think we're gonna wrap up here. And we're going to talk about test types tomorrow. All right. So does anybody have any questions? We have 5 minutes for questions. So please. Anything. You can ask anything. Could be from yesterday's. If there's something you didn't understand. Nothing? Okay. You understood everything. Robert, you muted yourself. You have a question?
Yes, yesterday we talked about verification and validation. So, and now we see that there is just a validation and on demonstrating readiness for deployment. So, if I switch now that word validation for verification, it doesn't matter, or?
Yeah. So verification is are we building it
Correctly?
Correctly, exactly. That's the specification. So you have the specifications, and here in the last stage of testing, you need the validation. Yeah, you might have built the system perfectly, just the way it is specified, but of course, it needs to be accepted by the users. This is where the validation comes in, and this can be things like, yeah, maybe we don't. Perhaps it could be some disagreement. For example, if you have a software testing team and they all tested and be like, okay, this is fine. I can work with this. But maybe a HR person would look at it differently. Maybe they have a different way of working, and perhaps they don't like how it is implemented, the different features. So yeah, it could be something like that. So this is the stage where you try to, yeah, validate the process. Okay. Anything else? Just any discussion question. Could be a word. Any words you're not clear about? You can just ask anything.
If there is no question, I just would like to mention that I worked in normal quality. I mean, I'm the new one in the AI quality, but in normal quality, I noticed that you've got in second stage, you've got like something like monitoring in previous page. Yes, and usually, if from my experience, the in Six Sigma or different methods, this monitoring, it's called like control or sometimes monitoring. It was always at the end of that cycle. So maybe if you thinking about if because there is a written that identify any issue of risk, I think that it's not good name for these steps, because it's against the all rules in the normal quality that you monitor everything almost at the end, and this identify of risk, it's called differently, not like monitoring. It's
Yeah, it is also called control. So yeah, it can be done. As I said, it doesn't have to necessarily be done as the second step. And in your case, it was done in the last step. But you have to, yeah, it is the stage where you track progress and identify, issues or risks, and see if everything goes accordingly. But yeah.
Thank you.
Okay, should we wrap it up? I don't know if Jagadish has any inputs.
We can wrap it up. We have another meeting in a minute.
Yeah. Okay. Yeah. Let's wrap it up then. And yes, tomorrow we'll also again same time. We'll do it the same format. We will have a quiz, and we will discuss the questions. And again, we will take a look at some concepts. Yeah. And okay, tomorrow we'll do test levels and more about the SDLC. Okay. Yeah. Good. Thank you.
Thank
And
you.
everybody.
Thank you very much. Thank you.
See you tomorrow.
I'll not be able to join.
Okay. This session is recorded, and
Okay.
I will of course upload all the words in glossary and try to make it more easy to understand. Try to break it down as much as I can. Right? Okay.
Yeah.
Yeah.
Thank you. Thank you for today.
Okay.
Thank you. Thank you. And tomorrow we will start like today or a little earlier, or because
We will start like today, 10:30. I'm unaware of any changes, so
okay.
it
Thank
will
you.
just start the same time. Okay.
Perfect. Thank you very much.
Okay.